Hi there. Yeah, I'm so excited to be again today with you. And yeah, we're just following the other talks. It was really great ones from Julian, from Alex, from Sebastian. And yeah, I was thinking today what could be interesting to this year we talk about. And yeah, as you heard everyone is talking about Nitro. That is coming from the full stack nature of Nuxt, and we are from all aspects pushing to have the best developer experience for Vue developers. Either it's like for the front end side or for the back end side, they are all together as a unified front. And Nitro is the several part of this full stack experience. My name is Pooya Parsa. I am also called PI0 or Pi0 because I like Pi number from childhood for some reason. I'm creator of Nitro. Maybe you're familiar with lots of packages that are in the behind the scenes on JS ecosystem, and also a core team member of Nuxt for years. I love cats. I have one cat here and of sushi, not too much. And you can follow me on social media. Probably if you already didn't join, Blue Sky is a really great social media platform that most of the great contributors and ecosystem already joined. You're more than welcome there. We can chat. And yes, so this is a precaution actually. Like I said, there was so many things that was explained in the talks before, so I didn't want to repeat them again. This topic is a little bit more advanced, but also an open discussion. So I will be looking at your chat. I have the chat open besides me. And during this presentation, I will show you some code from the internal of Nitro. Just wish me luck because I didn't practice. So yeah, it's just something more open. That today, if you are interested, if you want to know more about internals of Nitro, or you want interested to contribute to Nitro, I think that's the best opportunity now. Oh, nice sushi emojis there. Yeah, now I want to order. So, what is Nitro? Nitro is the second half of Nuxt. That's the full stack server engine of Nuxt. And we started Nitro as part of Nuxt 3 development. When you start Nuxt development server or Nitro development server or some other meta frameworks that support Nitro, it creates an isolated development service worker. And during dev, it puts all the code that you have in that server. You can quickly reload it, and every time you save, it's reloaded. When you want it ready and you want to build and deploy your application to production, it bundles everything. It combines different parts. First and most importantly is server-side rendering. That comes from your Nuxt application, your Vue components, and your other Nuxt stuff. Everything that Nuxt builds from Vite comes to one part. Nitro takes your also API routes and anything else that's related to the server and bundles everything together. But there is an important part in it. It makes sure that everything that is bundled is working, is going to be work in any deployment platform that you have, and it's taking care of that. How? With so many different things. First and most important part is that Nitro provides, and powered by some UnJS packages, provides some abstractions. Like for storage, it's not Node.js file system, it's an abstracted key-value storage that can be mapped to the Cloudflare storage, for example, or any other deployment like Redis or anything else. Like database, like WebSocket APIs, which is completely different between platforms and API handlers. We try to stick with the standard, and if there is no standard, we try to make something that is familiar, developer-friendly, and also compatible with most of the runtimes. So whatever you write inside Nitro and also powering Nuxt, it's agnostic. It can work anywhere. We also add Node.js compatibility to your deployment. So if you are deploying to platforms like Cloudflare Workers or using Nuxt Hub, which makes it also one more layer easier for you, all these layers, Nuxt Hub and Nitro, powered by a compatibility layer called unenv, which is also used by Cloudflare itself, try to convert everything you have, every dependency you have that is probably made for Node.js to be deployable to that platforms, which makes everything easy. And also we add web compatibility APIs for Node.js. Until recently, Node.js, until version 18, didn't have fetch, built-in fetch, and there are slight differences between Node and web platform, and we try to hide all these gaps so you don't feel there is a difference between these platforms. Everything works as you want. and anything else that the deployment platform wants. Sometimes when you build an application you want to deploy, they expect a specific format for your application. We will see it more how exactly it internally works. Or some of them require some configuration to be generated, and we always generate it for them. Who is using Nitro? Like I said, Nitro was made for Nuxt 3. It was part of Nuxt 3 development. So that was the first platform. For better testing and making it more open to the ecosystem, like everything else we do on UnJS, we extract it as a standalone server engine. But Nuxt is the official framework, meta framework that is using Vue and Nitro for server backend engine. There are other great frameworks like Analog.js that are joining, and there are other frameworks like SolidStack and TanStack, which you don't have exactly the same API surface, but behind the scenes they also leverage Nitro for deployment platform. So they have different conventions, but you can still use Nitro power to deploy to any platform you like. And we hope to extend it to the even wider ecosystem. I talked about UnJS. I'm pretty sure you heard about UnJS a lot. You probably saw some of the repositories there, and there is a single philosophy behind them. They are like Unix tools, like if you are using Linux. They do one thing and do it well. So instead of putting all the solutions and everything that we are going to make into one giant repository and just keep it for Nuxt or ourselves, we try to split them one by one. And by splitting them, we completely think about each of the solutions. We isolated that problems. We added tests for them. We cross-examined them. And then after making them published, we integrate them to the higher frameworks like Nuxt. One of the oldest packages there is Consula, which today has a lot of downloads. It's what gives you that beautiful CLI output that you have in Nuxt applications when you run a Nuxt dev. There are things like H3, which is the server framework. In Alex talk, he used H3 event handlers for being a server. It's like Express, but made for modern web platforms. There's an abstraction for a storage layer that is the storage layer of Nitro. There is abstraction layer for WebSockets and so many things. Also for like building a CLI, we wanted to make a framework for it, so it's City. And there is 50 more libraries there. It's a lot of things happening, and most of the times we made them because there was not a good solution. So we spent time to make that perfect. And if you have any ideas to add to this collection, it's always more than welcome. I regularly run a script to check the downloads. It's really surprising. Just to say the extent of it is like maybe more than 10 times of total number of downloads of React itself for this number of downloads. And I'm super glad every time I see these numbers. Of course, these numbers doesn't matter that much, but it means that we did something well. We started something good from Nuxt. We had good intentions for ecosystem health, and we try to make them as much as isolated as possible, as much as open as much possible. That made this number possible. If this tool wasn't truly open, we couldn't reach this number, and it makes me so much heartwarming. And I have to thank from many people that are involved in UnJS, probably more people than this, but UnJS and Nitro and Nuxt wouldn't be possible with this amount of people, that kind people that every day try to help on triage and contribution and helping on different areas. So back to our first thing, how Nitro works. It's a little bit complicated, so I try to use some visualizations first to explain the relationships between layers. If you are using Nuxt, probably from going high to low, it makes you much more familiar. Also, I'm seeing your comments. I will answer as fast as I can. I don't forget them. So inside the Nuxt application, Nuxt is a full stack framework, right? So it has an app, which is your client-side SPA, which is always there, and the server-side rendering. And there is a server for server routes. And that server is Nitro, like I said. And between them, between Nuxt and Nitro, we have so many UnJS libraries. Some of them are directly used by Nuxt, some of them by Nitro, some by both of them. UnJS is like the glue. Every solution we needed, it's on the UnJS. So it's like, behind. On top, it's Nuxt. And inside Nitro, there is a lot of stuff, a lot of abstractions, a lot of efforts, a lot of different things that today we will see it more in depth. So First, let's start with the big picture to see what is inside Nitro. Nitro, we call it the server engine for modern web applications. I mean, what is an engine, right? It's really hard to find a word for having a meta framework that is composable with other meta frameworks, and yeah, it's kind of unique thing. Nitro has three different parts. The first part is its builder. Builder is what's the job of Nitro. It takes your code, it combines it with Nuxt and every other code, any other library, and builds them together, whether it's in the development time for dev server or whether it's in the production. It's a builder at first, and it's using Rollup for that. Nitro also has a lot of runtime things. So it takes your code, it takes Nuxt SSR code, and it takes some internal code inside Nitro for your convenience, for converting conventions, for example, for WebSocket supports, for API handlers, for cron jobs, for storage, for many other things. And many of these runtimes are also powered by UnJS libraries. So Nitro is two things at least: a builder that combines everything and a runtime that adds power to the runtime. And interestingly, first, the code name of Nitro project was Sigma because it was like summing out of them, and we renamed it Nitro because it was more similar to Nuxt. And also Nitro provides some tools and API that makes it possible to compose Nitro with Nuxt. If you are using Nuxt, you're already using Nitro because these tools make it like glue. They work seamlessly together. And one of the most other important things is deployment presets. Deployment presets are something really powerful, something really unique to Nitro, something that we probably was the first and the only meta framework that made it possible this way open. And they are also really simple in the end. Powered by both builder and runtime API of Nitro, they are actually configuration presets that configures your Nitro application, whatever you build, when you want to build it for deployment, and deploying it, to add the entry point that's required for the runtime, add every configuration that it needs, configuring on env and on the other places, and prepare your application for deploying to the platform. So you don't need to change any single line of your code. You don't even need to add a single configuration because Nitro can auto-detect the preset during deployment based on the CI/CD environment. It's all magic, and all of them together work. The first part was builder, right? So Nitro has a builder that builds your input application. Builder works in two places. When you use Nuxt Dev or Nitro Dev, it starts a development server. The development server is an isolated worker, and inside it there is a rollup watcher. And soon we will replace it with Fleet for even faster reloads. But behind the scenes, it's a rollup instance right now and a development server. And when you are building your application for production, it's again same rollup configuration with combination of your current code, same thing that was happening in dev, and combining with the deployment presets that configure rollup for compatibility with the deployment platform and build it for production. So, Arias, can you explain about comparison between tools like Nitro, Vite, and Spot and macro frontends? Nitro is not comparable. Nitro, it's like a toolkit of different things. It uses Vite as a builder, Vite or Rollup or Webpack. Their job is to compile your code, actually, to make it like a package to deploy to the platform. Nuxt also uses Vite for building your front-end application and like SSR part of it. And Nitro also uses it. So it's like they are used by it. Also, spots, for example, like they are combined of like some static JavaScript assets and some HTML files. Also, Nitro serves them as static assets. So it's like a layer that makes those things possible. And also macro frontends, for example, if a big bundler like Webpack supports module federation, for example, we can combine these different things. It's something like layered. It's not replacing them, it's just using them, similar to Nuxt. The second part of Nitro, it's runtime API, which is huge, and we will hopefully have a little bit time to go to the details of it. I don't know how much time, but it's like it was amazing when I was creating the slides that how much we already created into the core of Nitro. It should be another framework, perhaps. at some point. So this is Nitro Runtime. In Nitro Runtime, we have so many things, but starting with API routes. API routes are powered by, if I can start another thing, H3 framework. H3 is like Express, and it provides a better API for creating event handlers. Nitro takes care of everything that you need, so you don't need to configure it yourself, but what you have to create is like an event handler, and this is the exports that you create. In a Nitro application, this is the sample of Nitro application, and if I run dev, this is what you write. And if we open it, I can create an HTTP, maybe. Yeah, this is what it says. And if I save it, it's immediately saved. How it works is a combination of the builder, which we will see soon, but you can already see some things inside it. If you open the Nitro or .Nuxt directory and open dev and index, you can see Nitro is generating this code. This is the runtime code that we was talking about. And it's not just your event handler, it's a lot of other features like tasks and cron jobs and everything. And it's also using ESM imports for faster reloads, because we don't bundle everything, we just bundle everything that we need. It's like having error capturing and many other things that if you was curious, you can just look inside it. If you use Nuxt, it's a little bit more complicated, but that's our code that is immediately bundled. And super fast already. It's sub-milliseconds, seconds, like 58 milliseconds, even though that we are even using rollup, not roll down, not native stuff like Beat. It's still fast. And yeah, we can also do crazy things like, I don't know if you heard about it, cat as a service. That's an amazing API that you can have cat pictures if you like. It's basically an URL that gives you a cat image. Instead of returning a string, you can return a fetch response like this. And I didn't test it, but I hope it works. If I open localhost, it's our code. It's just fetching it and returning as a response. Fetch returns a response object, and we can stream a response to the client. That's also one of the other features of Nitro. It can stream your responses, so they are fast. And yeah, it's easy. You can read more about other features of H3, but the goal was not to make something complex. Like most of the documentation you see, there is nothing in them. The reason is that we designed them in this way. We designed them to be simple as much as possible, nothing complicated. And yeah, don't look at them. Yes, so that was the API routes. We also have route rules. What if you want to create some API routes and you want to add some headers or like caching things on top of them? You don't need to write a lot of complex logic. You have to just use route rules. And inside route rules, you can say, okay, for every route, I want, for example, caching to be SWR and with a TTL of 60 seconds. That's it. Now our API can be cached. And as you can see, it's using cache control headers, and it's also faster. Behind the scenes, also Nitro used a layer called storage layer and also caching layer. Why we need a storage layer here? Like the answer is that we are caching things. If you are caching and storing a response, you have to keep it somewhere, right? But we don't want to have a Node.js dependency. We want the code and everything in Nitro works everywhere. So we use another layer called onStorage, which is an agnostic layer for storage, and it's also possible in Nitro build that you can directly use the storage to store your values. But if we are enabling this magical route rule, Nitro takes care of everything. Already in dev server, it configures the storage that is compatible with Node and dev server. Also, it integrates it with the caching layer. And you can see inside Nitro Cache, it's caching our responses. So that magic that was happening is literally there. It's just using the caching layer and storage layer in combination. A lot of things happen behind the scenes, combining configuration and runtime. Also, if you have a static assets, it's really important for full stack applications. you need static assets. When we build a Nuxt application, you always have some JavaScript assets. If you are using content module, you have a static content JSON files. So it's essential for a full stack application to have all these building blocks. You need API routes, you need caching, you need storage, you need static assets to be served, also based on the environment, to sometimes also configure the deployment platform. We need plugins sometimes to add some logic to the server, to extend the server. We even might need a database, which is another feature, and it's called DB0. You don't need to configure it. It's already there, and you can use any database provider you want, only with something that is already there. You can enable the experimental flag, and as Alex mentioned, that the reason it's experimental is that we are evaluating community feedback. And believe it or not, you can just write it down inside another application. You don't need to configure anything. You don't need to install and run a server instance to do it. It just works. There was a question, so SWR saves response locally instead of just leaving another layer to handle it, right? Right, and more. So if you can see in there here, it's also setting a cache control. It's saying both the CDN layer, hey, please keep this response. If someone hit you within 60 seconds to respond it, do not call my function again. And also, it sends this header. So if in your browser or users in their browser, they visit the page once, they don't even need to hit the CDN layer anymore. It's adding both headers for the clients and also CDN configuration. Yeah, there are so many things. There's also tasks. That is something that is not per request, but what if in your server you want to do something in background? You want to check your users. You want to calculate your like summary of like payments per day. So you can use a feature called tasks. It's making it Nitro really a runtime platform with a lot of features. And if you are more interested to know more about Nitro Internals, the big chunk of the things are inside source core for like dev server if you want to read. In rollup, there is like this huge configuration that says how Nitro actually combines everything. It's again not magic. There are all solutions that we thought about to make them as simple as possible. And they are like small plugins for everything. Like for TypeScript support, we have a simple, small ES-Build integration. For externals handling, which is one of the most powerful things of Nitro, we'll see soon, it is here. If you want to see like how Nitro creates its handlers, it's here. How the storage layer integrates, it's here. Nitro basically generates some code that integrates on storage with your server application. There are so many easy to read things, and if you have any questions, feel free to always create an issue or discussion. We will love to have more contributors, people that can understand in terms of Nitro and make them simplified. And all that runtime features I was talking about are here. You can see it's really simple for this. Nitro generates something like this and creates a use database composable that is an auto-imported utility. So we can use database out of the box. For storage, it's very simple. It's like a composable that it can give you access, and for other things. And one other thing I mentioned before, there was deployment presets. So if I go here, I come back here, and instead of dev server, I just build it for production. You can see there is some nice logs. And it's saying, I built your server with this compatibility date for Node server compatibility, because that's the default for us. And there are some output files. Everything that the result is, it's inside the output directory. All we have to deploy is this output directory, not this huge Node modules, which I think even we optimize it, it's 150 megabytes. We don't really need that. It's just 170 kilobytes, and it's going to be even less in Nitro version 3, because that's all we need. And if there is any public assets, it's going to be public. And if there is any server assets, it's just making a compact bundle of them. If we add any dependency, like, I know, Faker.js. What was the Faker.js dependency? It's really hard with npm packages, especially if it's updated. And how it works. Let's just log it for now. The point is that if you use a dependency like this and you build your application, that's how it works. Yes. So if you are using some dependencies, you don't need that huge amount of the Node.js dependencies. We use a library from Vercel called Vercel NFT inside Nitro, which is inside externals.ts, that if you can read about how exactly it works, it creates a model graph and extracts exactly what we need for basically our dependencies. If you can see, like in node modules of Nitro output, there is only one dependency, Flaker.js. That makes this output directly portable. We don't have like a package JSON with dependencies. It's like a bundle dependency, and it's all that's required for us to deploy everything to production. And also we have WebSocket layer, which is was one of the really complex things that I had been working on, because why? Platforms would agree on something. You can see inside, I think here, yeah, there is a huge complex table about all the differences. If you just want to use a simple WebSocket in different deployment platforms between different runtimes, there's tons of differences between them. And yeah, we had to unify these two all together. All you have to do in Nitro is just create a simple hook like this. You don't have to care about differences between platforms, and Nitro and UnJS libraries take care of that for you. I talked about two parts. Runtime probably was so big, so sorry I couldn't have time to go more deep into each of these parts, but I hope that gives you some vision. And Nitro also have some tools, like we have a CLI that's powered by C12 for directly using Nitro. We have an upcoming kit and module system to extend Nitro Core, but with some differences from Nuxt. Nitro uses the same config loader as Nuxt called C12, which does all the magic. It has an open API generator, so as long as you have some routes, you can enable open API, an experimental flag for now. And some issues, probably remove it for now. Insert Swagger, and yeah, it just generates our API routes, and that's for our main route. If you have some parameters, they will be shown here. But the instance is that Nitro provides so many other tools, not only runtime, not only build time, but also add-ons like this, and also route rules for tools. Thank you so much for attention. We just created a new Discord channel, and we are shaping a new community under Nitro.js. This is the repository that you can join and collaborate, and we have also a community section that we started creating a dedicated team. We're already inviting some people. I think we have 20 plus people from like also contributors and more, and I would love you to see you there. You can also type in Blue Sky, and yeah, I will wait for a little bit to look at the questions if you have anything in particular.
We have lots of questions. Lots of questions. All right, let's get started with, and some of them I know you were looking at the chat at the same time, so we might ask questions that have already been answered, but just to make sure everybody hears it. Any major performance wins coming down the pipe in the Nitro for SSG or for CF pages?
So yes, one in particular to mention is that even if we have a full static deployment, we still sometimes need a server. There are some additional things that after mounting the application, we need, for example, just imagine you have a weblog. It could be SSG, but you will need the counter of the live visitors. We can add it at top. So I think that's the first thing that you always could win by having a backend down the pipe. With Clover pages also, I think it's like their focus was first on the static assets, but there's always something that you want in addition. So I would say the server would never hurt to have it there. And also, like, for example, you saw the talk from Sebastian. Like for authentication, for example, we always need the server for secure authentication mechanism, even if like the site is full SSG. There are cases like e-commerces even that you want some SSG applications, like the pages are statically generated, but we need some add-ons on top of them, like authentication after mounting applications. So that comes in handy, I would say.
Thank you. All right. What is your opinion of using Dino 2 when starting a new Nuxt project? Is it stable enough for a production project, or would you keep it for experiments at the moment?
Well, to be frank, I haven't well tested Dino version 2. I had really friend chats with their team. I know they are doing a lot of efforts, which I really appreciate for Node.js compatibility. So at least it works out of the box. It's stable, it works. And yeah, they're also respecting a lot for web standards and also like protection. For example, if the permissions are opt-in, like your application doesn't have file system permission or environment variables access unless you give it to it. So it's a really secure and modern runtime. I would really suggest to try it. I would personally use Node.js as my default runtime for timing because it's like the de facto standard. But these options are really worth to try, and they have really good teams behind them.
Great, thank you. All right. Can you explain a bit more about your comparison view on tools like Nitro, Vite, BinServ, SPAs, and micro front ends?
Yeah, I think I quickly explained it during my talk. The thing is that they are like not comparable. They are composed together. We use Vite now in Nuxt, and we plan to use also Vite inside Nitro as a plugin, so it's possible. Also SPAs and macro frontends, like SPAs also like static assets basically. Nuxt also can generate them, and Nitro can serve them. And macro frontends are also, I think, a wider concept. But for example, Webpack module federation is something that we are also investigating for Nuxt. So basically, they just come together. They are not comparable.
I like that. Thank you for reiterating. All right. In the future, do you see the Nitro builder using something like RSPack, Roll Down, or TurboPack?
So yes, definitely we are investigating at least roll down integration as an alternative bundler because it's compatible, API compatible with rollup. It's an easy migration, and we probably do it with the current Nitro version 2. Like as mentioned, we are also investigating the Vite integration. I'm not sure about RSpec and TurboPack. It's something that needs more community efforts because in the source code we are heavily depending on the rollup ecosystem. And because rollup is also compatible with Vite. So we are a little bit linked more about towards the things that are compatible with with rollup, like Vite or roll down. But others, I don't see any blockers as long as someone can make the compatible plugins for them.
Thank you. Okay. And will Nitro 3 support async context use event in Cloudflare workers?
Oh, thank you so much for mentioning it. That's actually like, to be honest, most of us internally like talking with Sebastian time to time. We are really looking forward to enable this composable. It's there already. You have use event. There's an experimental flag for it, and it's already super stable for Node.js support. Cloudflare Workers also supports it, but supporting Node.js compatibility with them, we have some internal discussions going on. There is an internal proposal that is going to be open soon that makes Nitro able to auto-configure the Cloudflare platform. But this is something we really are looking forward, and I hope to backward it also for Nitro version 2, because it unblocks us for many things, including like OpenTelemetry and sensor integration for making magical things for Nuxt Hub. It's something really important, and we want to unblock it as soon as possible.
Thank you. All right. So SWR saves a response locally instead of leaving another layer in CDN browser to handle it.
Yes. So yeah, I already also mentioned it's up to the CDNs to keep that response or not. SWR feature, built-in caching feature of Nitro, locally stores it. So it works with or without a CDN or without a supported CDN, in fact. But both CDNs, edge layers, and end-user browsers can optionally also cache that layer, cache that content, so we don't hit the Nitro server every time. It's an additional benefit. But at core, yes, Nitro always does that storage because we want to be compatible as much as possible. You don't need to spend a lot of money to just choose a CDN if it costs you. And the important part is that you can always opt out. So you can make the stability or caching headers only. There's a route rule for it. And it only adds the headers to hint the CDNs without storing it.
Thank you. Okay. Where is the cache saved? And is it file system or in RAM? And can we control where the cache is saved?
Yes, so that's a good question. On storage is like a file system, like with different mounts. By default, on storage, that is the storage backend for caching layer is in memory. So a default on storage instance for cache is in memory. But Nitro for the supported platforms for Node.js deployments and local dev, also if you use, for example, Nuxt app that automatically configures, they add a storage automatically to it. So it depends on your deployment platform for the default. You can always change the backend. You can mount to the cache for a Redis storage, for example. You can even disable it with DevNow. But by default, it depends. It could be either in RAM or file system. And we are also looking forward to find a solution to have multi-layer cache. So it could be both in RAM and file system. RAM is much faster, but it's expensive. So we keep important stuff in RAM, and for more caches, we store them in the file system with multi-layer.
Very cool. Oh, I like this one. Love using Nitro. Was wondering about support for running the dev server in Worked. Is it waiting for Vete's new environment API in version 6?
So we have currently a community module that adds simulation for Workerd in dev server for Nitro. It's not depending on which environment API in version 6 is something standalone, but we hope to be also be compatible with environment API. So we don't reinvent the wheel actually. But yes, this is definitely something planned to support both via this with integration support and also standalone Nitro dev server. That's in the plan.
Thank you. And last question. How much fun will you have migrating from roll up to roll down for Nitro next?
I would say a lot. I can't wait to have some time to start doing that. I was also in discussion with Ivan earlier this morning that we want to do this. It's something exciting because I imagine it's not that hard. We can also find the differences between roll down and roll up to also help to shape that stable release. But I think it would be fun, and probably I will share some updates in my social media. So if someone wants to ever try, I think we can do it together.
Awesome. Thank you so much. And thank you again for joining us, Pooya. We greatly appreciated it.
Of course. Thank you for having me, and have a nice